Section 210.63 of the National Electrical Code addresses the requirements for receptacle outlets serving heating, air conditioning, and refrigeration equipment. Specifically, it mandates that a 120 volts single-phase receptacle outlet must be installed on the same level and within 7.5 meters or 25 feet of the HVAC equipment it is intended to serve. This requirement ensures convenient access to a power source for servicing and maintenance of the equipment. The question that often arises concerns the definition of same level in the context of lay-in ceilings and equipment installed above them, such as fan-powered boxes or heat pumps. The key point to understand is that a lay-in ceiling, also known as a suspended ceiling, does not constitute a separate level for the purposes of complying with Section 210.63. This means that if HVAC equipment is located above a lay-in ceiling, the required receptacle outlet does not necessarily need to be installed above the ceiling as well. Instead, a receptacle outlet located at the floor level is generally considered compliant with the code, provided that it meets the distance requirement of being within 7.5 meters or 25 feet of the equipment. This interpretation is based on the understanding that the lay-in ceiling is primarily an architectural element and does not fundamentally alter the accessibility or servicing requirements of the HVAC equipment. From a practical perspective, installing a receptacle outlet above the ceiling can present several challenges, including limited accessibility, potential safety hazards, and increased installation costs. Therefore, the flexibility to install the receptacle outlet at the floor level provides a more practical and cost-effective solution while still meeting the intent of the code. However, it is crucial to ensure that the receptacle outlet is readily accessible and not obstructed by furniture, equipment, or other obstacles that could hinder its use during servicing and maintenance. In situations where the distance between the floor level and the HVAC equipment exceeds the 7.5 meter or 25 foot limit, or if there are other specific site conditions that make a floor level receptacle outlet impractical, alternative solutions may need to be considered. These solutions could include installing a receptacle outlet on a wall or other suitable location that is closer to the equipment and still within the allowable distance. In such cases, it is advisable to consult with a qualified electrical inspector or engineer to ensure that the installation meets all applicable code requirements and safety standards. It is also important to consider any local amendments or interpretations of the National Electrical Code that may be in effect in your specific jurisdiction. Local codes can sometimes have additional requirements or clarifications that may affect the installation of receptacle outlets for HVAC equipment. Therefore, it is always best to verify the applicable code requirements with the local authorities before proceeding with any electrical work. In summary, when HVAC equipment is located above a lay-in ceiling, the required receptacle outlet under Section 210.63 can typically be installed at the floor level, provided that it is within 7.5 meters or 25 feet of the equipment and is readily accessible for servicing and maintenance. This interpretation offers a practical and cost-effective approach to code compliance while ensuring the safety and convenience of electrical installations. Remember to always consult with qualified professionals and local authorities to ensure compliance with all applicable codes and regulations. Let's delve into some additional considerations regarding the installation of receptacle outlets for HVAC equipment, particularly in the context of the National Electrical Code, NEC, and its specific requirements. Firstly, it's important to clarify the general intent behind NEC Section 210.63. The primary goal is to provide a readily accessible power source for the servicing and maintenance of HVAC equipment. This accessibility ensures that technicians can safely and efficiently perform necessary tasks without relying on extension cords or other temporary power solutions, which can pose safety hazards. The 7.5 meter or 25 foot distance limitation is designed to keep the receptacle outlet within a reasonable proximity to the equipment, minimizing the risk of tripping hazards or other accidents associated with lawn extension cords. Additionally, the requirement for the receptacle outlet to be on the same level as the equipment aims to prevent situations where technicians have to navigate stairs or other level changes while carrying tools or equipment. Now let's consider the specific case of HVAC equipment installed above a lay-in ceiling. As we discussed earlier, A lay-in ceiling typically does not constitute a separate level for the purposes of NEC Section 210.63. However, there may be situations where the height of the ceiling is such that a floor-level receptacle outlet would be impractical or unsafe. For example, if the ceiling is exceptionally high, the distance between the floor and the equipment could exceed the 7.5 meter or 25-foot limit. In such cases, it may be necessary to install a receptacle outlet closer to the equipment, even if it means placing it above the ceiling. However, this should only be done after careful consideration of the potential challenges and safety hazards involved. One potential solution is to install a receptacle outlet on a nearby wall or structural element that is within the allowable distance of the equipment. This can provide a more accessible and convenient power source without the need to access the space above the ceiling. Another option is to install a dedicated receptacle outlet box above the ceiling, but with a flexible conduit extending down to a more accessible location. This allows the receptacle outlet to be easily accessed without having to climb into the ceiling space. When installing a receptacle outlet above a lay-in ceiling, it is crucial to ensure that the installation meets all applicable safety standards. This includes using appropriate wiring methods, grounding techniques, and overcurrent protection. The receptacle outlet should also be clearly labeled to indicate its purpose and voltage. Additionally, it is important to consider the potential for moisture or other environmental factors that could affect the safety and reliability of the electrical installation. In some cases, it may be necessary to use a weatherproof receptacle outlet or other protective measures to prevent corrosion or damage. It is also important to remember that the NEC is not a design manual. It provides minimum safety standards, but it does not dictate how electrical systems should be designed or installed. Therefore, it is always best to consult with a qualified electrical engineer or contractor to ensure that the installation meets all applicable codes and standards, as well as the specific needs of the application. In addition to the general requirements of NEC Section 210.63, there may be other NEC sections that are relevant to the installation of receptacle outlets for HVAC equipment. For example, NEC Section 210.8 requires ground fault circuit interrupter (GFCI) protection for receptacle outlets installed in certain locations such as bathrooms, kitchens, and outdoor areas. While HVAC equipment is not typically located in these areas, it is important to be aware of the GFCI requirements and to ensure that any receptacle outlets installed in potentially wet or damp locations are properly protected. Another relevant NEC section is 210.12, which requires arc fault circuit interrupter (FSI) protection for receptacle outlets installed in dwelling units. While this requirement does not typically apply to commercial or industrial installations, it is important to be aware of it and to ensure that any receptacle outlets installed in residential HVAC systems are properly protected. Furthermore, it's crucial to understand the terminology used in the NEC and how it applies to the installation of receptacle outlets. For example, the NEC distinguishes between receptacles and outlets. A receptacle is a contact device installed at an outlet for the connection of an attachment plug. An outlet is a point on the wiring system at which current is taken to supply utilization equipment. Therefore, a receptacle outlet is a combination of a receptacle and an outlet providing a point of connection for electrical equipment. When installing receptacle outlets, it is important to use the correct type of receptacle for the application. The NEC specifies different types of receptacles for different voltage and amperage ratings, as well as for different types of equipment. For example, a 120 volts, 15 amps receptacle outlet is typically used for general purpose applications, while a 240 volts, 30 amps receptacle outlet is typically used for larger appliances or equipment. It is also important to use the correct wiring methods for the installation of receptacle outlets. The NEC specifies different wiring methods for different types of construction, as well as for different environmental conditions. For example, non-metallic sheet cable, also known as Romex, is commonly used for residential wiring, while metal conduit is typically used for commercial or industrial wiring. When installing wiring, it is crucial to follow all applicable NEC requirements, including those related to conductor size, insulation type, and grounding. In addition to the NEC requirements, there may be other codes and standards that apply to the installation of receptacle outlets for HVAC equipment. For example, the International Mechanical Code (IMC) may specify requirements for the location and accessibility of HVAC equipment, which could affect the placement of receptacle outlets. Similarly, the International Fire Code (IFC) may specify requirements for fire stopping and other fire safety measures, which could affect the wiring methods used for receptacle outlets. Therefore, it is important to be aware of all applicable codes and standards and to ensure that the installation meets all requirements. In summary, the installation of receptacle outlets for HVAC equipment requires careful consideration of the NEC requirements, as well as other applicable codes and standards. It is important to understand the general intent behind the NEC requirements, as well as the specific details of each section. It is also important to consult with qualified professionals and local authorities to ensure that the installation meets all applicable codes and regulations. By following these guidelines, you can ensure that the installation is safe, reliable, and compliant with all applicable requirements. And remember, electrical work can be dangerous, so always take precautions and consult with a qualified electrician if you are not comfortable performing the work yourself. Now let's expand on the practical implications of complying with NEC Section 210.63 when dealing with HVAC equipment situated above lay-in ceilings in various real-world scenarios. Consider a commercial office building where multiple fan-powered boxes are installed above the suspended ceiling to provide localized heating and cooling to different zones. Each fan-powered box requires a dedicated 120 volts power source for its motor and controls. In this scenario, the electrical contractor has a few options for complying with NEC Section 210.63. Firstly, they could install a receptacle outlet above the lay-in ceiling within 7.5 meters or 25 feet of each fan-powered box. This option would require careful planning to ensure that the receptacle outlets are accessible for servicing and maintenance. The contractor would need to consider the layout of the ceiling grid, the location of other equipment and utilities, and the potential for obstructions that could hinder access to the receptacle outlets. Additionally, the contractor would need to ensure that the wiring methods used above the ceiling are appropriate for the environment and comply with all applicable NEC requirements. Another option would be to install receptacle outlets at the floor level within 7.5 meters or 25 feet of each fan-powered box. This option would be simpler and more cost-effective, as it would not require accessing the space above the ceiling. However, the contractor would need to carefully consider the placement of the receptacle outlets to ensure that they are readily accessible and not obstructed by furniture, equipment, or other obstacles. The contractor would also need to ensure that the distance between the receptacle outlets and the fan-powered boxes does not exceed the 7.5 meter or 25 foot limit. In some cases, it may be necessary to install multiple receptacle outlets to ensure that all fan-powered boxes are within the allowable distance. In a retail store with a similar layout, the considerations would be much the same. However, the presence of merchandise displays and customer traffic could add additional challenges to the placement of receptacle outlets. The contractor would need to work closely with the store owner or manager to ensure that the receptacle outlets are located in areas that are both accessible and unobtrusive. In an industrial setting, such as a manufacturing plant, the requirements for receptacle outlets for HVAC equipment may be different. Industrial environments often have higher voltage and amperage requirements, as well as stricter safety standards. In these cases, it may be necessary to install dedicated branch circuits and receptacles for each piece of HVAC equipment. The contractor would also need to consider the potential for exposure to harsh chemicals, moisture, or other environmental factors that could affect the safety and reliability of the electrical installation. In a healthcare facility, such as a hospital or clinic, the requirements for receptacle outlets for HVAC equipment are even more stringent. Healthcare facilities have strict requirements for infection control, patient safety, and electrical reliability. In these cases, it may be necessary to install isolated power systems and other specialized electrical equipment to ensure the safety and reliability of the HVAC system. The contractor would also need to work closely with the facility's engineering and maintenance staff to ensure that the installation meets all applicable codes and standards. Regardless of the specific application, it is important to carefully consider the placement of receptacle outlets for HVAC equipment to ensure that they are accessible, safe, and compliant with all applicable codes and standards. The contractor should also work closely with the building owner or manager to ensure that the installation meets their specific needs and requirements. In addition to the practical considerations discussed above, there are also some legal and regulatory issues to consider when installing receptacle outlets for HVAC equipment. In many jurisdictions, electrical work must be performed by licensed electricians who have the necessary training and experience to ensure that the installation is safe and compliant with all applicable codes and standards. It is also important to obtain all necessary permits and inspections before beginning any electrical work. Failure to do so could result in fines, penalties, or even legal action. Furthermore, it is important to maintain accurate records of all electrical work performed, including the location of receptacle outlets, the wiring methods used, and the results of any inspections or testing. These records can be valuable in the event of a future electrical problem or when performing maintenance or repairs. In summary, the installation of receptacle outlets for HVAC equipment requires careful planning, attention to detail, and compliance with all applicable codes and standards. By following these guidelines, you can ensure that the installation is safe, reliable, and meets the needs of the building owner or manager.